A new report sponsored by the US-based Commercial Space Federation finds that China could surpass the United States as a leader in outer space over the next 5 to 10 years. Meanwhile, Chinese scientists have discovered that the mantle on the far side of the moon is cooler than the near side. The discovery comes after analyzing soil samples collected by China's Chang 6 lunar probe. Zhang has more in this report.
The far-side lunar samples are opening up new pathways to deepen our understanding of the moon. Chinese scientists have announced new findings indicating the lunar mantle on the moon's far side is colder than that on the near side. This is based on investigation into the petrology and geochemistry of the returned lunar basalt fragments. Specifically, Chang 6 basalts from the far side, dated at 2.8 billion years ago, showed a mantle potential temperature roughly 100 degrees Celsius lower than that of near-side basalts returned by the Apollo and Chang 5 missions. This represents the first of its kind study.
I think the most important in the scientific discovery is that it can offer a new angle about the hemispherical differences, for example in mantle temperature on the moon. It will inspire people to have further and deeper research.
These new findings were achieved through multiple approaches by scientists from this research institute, as well as Peking University and Shandong University. The results have been published in Nature Geoscience.
Starting from the Chang 6 lunar samples, all the previous speculations on the far side have physical evidence to verify them. And the new theories also need them for support. This is unique.
In 2022, the discovery of the new mineral on the moon was announced by the research institute based on the analysis of the near-side lunar samples from the Chang 5 mission. Now the new findings are being unveiled based on the far-side lunar samples from the Chang 6 mission. And through the joint efforts of scientists, we're expecting to gain more knowledge about the lunar formation and evolution and beyond. Zhang Yibing, CGTN, Beijing.
Later, we'll talk with the retired Canadian astronaut Chris Hadfield. But first, let's get to our panel. Yuguang chairs the Space Transportation Committee at the International Astronautical Federation. Amitabha Ghosh is a U.S. space scientist working on NASA's Mars missions. And Zhang is an associate professor of astronomy at Beijing Normal University. Thanks to all of you for being with us. Zhang, let me start with you, and let's begin with those soil samples that were recovered from the far side of the moon. What do they tell us, and what does it mean that they are cooler on, or the surface is cooler on the far side of the moon rather than the near side?
Right, so the two sides of the moon actually look quite different. So on the near side, the face facing us, we can see darker areas. They're basically lunar moraines. They're formed from late-time sort of lava flows, but you don't see those on the backside of the moon, which means the two surfaces solidified at different ages, at different times. And this vast difference informs us on how the moon was formed. So the leading theory is that a Mars-sized protoplanet collected with Earth, and then the splash, the debris from the moon. And through this process, the side of the moon facing Earth, the really hot Earth back then, would have a different temperature from the backside. And this particular sample taken from the moon and being analyzed sort of verifies that there is indeed this temperature difference when the solid or when the rocks were actually formed. So it's an important step in observationally actually verifying important moon formation theories.
And Zhang, what do they tell us? What do these samples tell us about the potential for humans living on the moon?
Right. Some of the lunar rocks, it's difficult to extract, but they contain a lot of hydrogen in them, and there's also oxygen. So if you can do proper chemistry, you can have substantial facility on the moon, then there's the possibility you can manufacture water out of the lunar dust material without even going into the bottom of the craters to extract the proper ice. This kind of analysis tells you lots of the kind of in situ resource utilization you can possibly do, and depending on your technological level and how much equipment you want to carry to the moon, that gives you different potentials for the size of the human settlements on the moon. So you need to know first.
Right. Amitabha Ghosh, great to have you with us. Now, you have called the moon the new frontier for space exploration. Let's look at one scenario. Let's say when a permanent lunar base has been established on the moon, what will it be able to tell us? What are the scientific questions that will be answered about our own planet, Earth, as well as our solar system?
See, I think when I call moon the next frontier, it is more in the context of, I think Mars is 200 million miles away. Moon is just under 0.4 million. So it takes 3 days to go to the moon. It takes 6 months to go to Mars. So from that perspective, the moon is very interesting for human exploration. And that's what I meant. So it's not as much as the scientific questions, which has been figured out. A lot of it has been figured out in the last 50 years. But for humans to settle there, to try in situ resource utilization. What is in situ resource utilization? Living off the land on the moon. The reason America could be colonized or could be settled into is because you could grow, you'd find oxygen, water here. Similarly, if you go to the moon and you can find oxygen and water in a readily form without having to carry back from Earth, or say if there was a crew emergency and somebody needed to be brought back. So in that context, moon is really the next frontier for human exploration.
Young Yuguang, so far there have been something like 200 scientific papers that have been published using these samples that China's lunar modules have brought back. It gives us new insights into the moon's origin and evolution. What are China's priorities for lunar scientific research, with particular reference to things like water, ice, and also helium?
Other panelists have already mentioned the water is a very important resource on lunar surface. It's not only drinkable for our astronauts who will be the researchers in the lunar base in the future, but also it can produce hydrogen and maybe other propellants on the lunar surface. The point is, if you want to go deeper into the solar system, for instance, maybe in the future, not only we can have a base on the lunar surface, but on the Martian surface, reducing the cost, especially reduce the cost for the transportation system, will be very, very critical for Earth. The analysis from the scientists and engineers has already found that if you can produce your propellants on the lunar surface, because the low gravity on the lunar surface, it will be much cheaper than producing the propellants from the Earth and brought to the outer space. So this is a point of the importance, as mentioned by Dr. Amitabha Ghosh, the frontier. Also, this output for human beings can make it cheaper for Earth to go even, for instance, in the future, not only go to Mars, but also go to the Jupiter system and even beyond. So this is the meaning for the exploration. From the view of exploitation, you know that because of the low gravity, if in the future our production on the lunar surface can grow to a certain scale, the products, for instance, some electronic and other devices for spacecraft can be produced on the lunar surface. And it is very interesting. If you bring these products from the lunar surface to the geosynchronous orbit, you know that for TV broadcasting, geosynchronous orbit is very, very important. But it will be cheaper than bring that from the Earth. So this is very interesting.
Zhang, China has launched multiple expeditions, missions into space, to the moon, to Mars as well. But now it's also collaborating with Russia, with Pakistan, with Egypt as well. How does that collaboration strengthen China's lunar exploration efforts?
Right. So the collaboration with Russia started very early on. So the International Lunar Research Station that is planned for 2035, with the first phase will be finished, and then after that, the more substantial phase is planned. So this research station is actually, as the name suggests, is a research station. So there's going to be a lot of scientific experiments. I mean, some study on the astronomy side of things, and then the discussion with the Russian Space Agency goes back right from the beginning of the conceptual stage of this station, and joint studies have been carried out on what kind of astronomy can be done, what kind of other projects can be done. So obviously the Russian Space Agency has a lot of expertise, and the Pakistani Space Agency has been collaborating very closely with China, especially on the manned program, because the need to monitor return astronauts, Chinese astronauts, that flies over the Pakistani sort of above their airspace. So they contribute in different ways, and they all substantially, either from monitoring or, in the Russian case, actually, nuclear batteries, the batteries that can keep instruments alive in the long, cold lunar nights. Russia is probably the best, if not only, source of that technology at the moment. That all of that sort of adds to the viability of the research station, which will be substantial given it's a station. So you need all aspects of things to work out, and the more fronts, the better in that respect.
Chinese companies and organizations displayed technology, promoted collaborations, and showcased progress in their lunar and satellite programs at the International Astronautical Congress, which was in Sydney in Australia. CGTN's Wu Li was there and has this report.
It's a prime opportunity for exchanges and collaboration, with more than 450 exhibitors negotiating partnerships that could reshape the global supply chain in the space sector. It's my third time covering this space event. As usual, the exhibition area is full of innovations and solutions. But it's clear this time that a growing number of space companies showcasing their cutting-edge technologies are from China. As the commercial space industry is booming across the world, dozens of Chinese companies are aiming to tap into the global market with their quality satellite technologies and component services.
Telecom operators, satellite manufacturers, as well as satellite users. We have made over 10 partners or clients who have been here. We have some discussions, collaborations, and even before we come, we already established some memorandum of understandings, some NDA signed, and some documents already being inked.
With a growing number of satellites and mega satellite constellations, data processing and ground station service demand is surging.
We also have the ground station in Africa, in ASEAN, in Argentina, in South America. So based on this ground station, we will open the overseas market. So until now, we at least to provide service at least 10 countries.
Advanced technologies such as AI and quantum computing are transforming industries worldwide. Enhancing computing capabilities in space has now become a key focus within the global space community.
We provide computing services to all our customers. So basically, whenever your device or your system could generate a large amount of data in space, and then we can process this data with a more efficient way.
Global space experts welcome and encourage more Chinese space companies to strengthen collaboration with the international space community.
And we see that this is taken up by a very quickly emerging space ecosystem on the commercial market in China. We appreciate that very much, and we can just open our arms and welcome any other new upcoming commercial entity, commercial companies from China.
I think there is a lot of potential for Chinese companies, so I hope in future to see more Chinese companies at the IAC.
There are over 500 commercial space companies in China, from single satellite to mega constellation networking, and from data collection to AI processing services. China's commercial space industry aims to work with more global partners to reshape the global space economy. Wu Li, CGTN, Sydney.
Amitabha Ghosh, as we heard there in that report, there was something like 7,000 delegates at that meeting that took place in Sydney in Australia. Now, when we hear about scientists and companies talking about the global supply chain in the space sector, what does that mean?
Well, so space is a huge business. You have many engineering subsystems, and so these services for each of these subsystems has to be sourced from different companies and different countries. And so that was that's what the global supply chain means.
Yang Yuguang, China's space program stands as one of the most significant and rapidly advancing technological enterprises of the 21st century. What benefits does it bring, and what kind of partnerships do you see emerge from this?
Well, China always recognize ourselves as a big country now in the whole space sector, but not a leading country in the world. So still we have a long way to go to becoming a leading country in this world. So we still have a long way to go. Although we already have great achievements, especially as you mentioned, and other our panelists have already mentioned, in manned space flight, in deep space explorations, in lunar explorations. But still, to become a leading country in space field, we need the breakthrough in many fields, not only, for instance, our manned space station, our future human missions to the moon, right. And also, as we've already discussed, our outpost, our the International Lunar Research Station on the lunar surface. Also, during this process, the international cooperation reviewed by the white paper of China's space activities, it recognized the international cooperation as one of the most important benchmark to becoming a leading country in this field. So for this reason, that is, we should have more broader and also deeper cooperation with other countries. As mentioned by our colleagues during the International Astronautical Congress, we not only have the ground stations in other countries, also from the upstream, from the providers of the subsystems, parts, and also devices, and to the downstream, to the applications and the data handling, and also the use together with the utilization of AI technology, we need more cooperation with other countries. This will not only benefit ourselves, but also benefit the whole world, not only the space sector, but also to bring more knowledge, and also profit to our human being.
Yeah, Amitabha Ghosh, I've just got a minute left. What do you see as the next major frontier in space exploration beyond Mars?
Well, I think the outer planets are going to be very important. The moons, or some of the moons of the outer planets, like Europa is the moon of Jupiter, below the crust, 10 miles below the crust, there is an ocean bigger than the Pacific Ocean. And the thought is that, well, on Earth, life originated on the oceans. And the oceans on Earth are dark below 1 kilometer or 1 mile. So here, the oceans in Europa are also dark. And so the natural question is there life originated, did life originate in those oceans, in these satellites? And are they still there? That's a very, very big question. So that is what is going to redefine the search for life. That is what's going to redefine the science in this century.
Okay, well, that's where we have to leave it. Thanks to all of you for being with us. Joining us now is retired astronaut Chris Hadfield. He flew in space 3 times, becoming the first Canadian to walk in space and serve as commander of the International Space Station. He is also a writer. His new novel is a thriller called Final Orbit. Chris, great to have you with us.
Good to be back with you. How have you been?
Great, have been great. You look great as well. Great to have you with us. Chris, you went into space in 1995, you went up on the space shuttle, docking with the Russian space station Mir. That was 30 years ago. Of course, a lot has happened since then. As of March this year, looking at the numbers, citizens from 47 countries have traveled to space. Talk to us about the evolution of space travel.
You know, the whole thing was limited by the launch vehicles that were available. Early on, just starting with Sputnik, of course, before I was born, but the ability to build a machine that could take first satellites and then people to orbit, that was the great choke point. And early on, the only 2 nations, the superpowers, you had to be a trillionaire in order to fly in space. And that became the great throttling limiter on who had access to space. But technology improves, both since 1957 and since my first space flight in 1995. And that's what has really wrought the huge changes, and why, as you say, nearly 50 different countries of people have been to space. It's because the technology has gotten better, things have become safer and simpler and therefore cheaper. And that opens up the door, just like all of our previous modes of transportation in history.
Now, you served as commander of the International Space Station, as I mentioned. What was that experience like?
It was an enormous responsibility for the lives of my crew, because on board a spaceship, you are a tiny aluminum bubble of air living in a place of extreme hostility and instant death if there's anything punctures that bubble. And the space station is also almost 40-year project between 15 leading nations of the world. So there's a huge amount of time and money and work invested in it. I don't know how you even value it, 150 billion US dollars perhaps. So as the commander, I felt that every single day. The necessity to do my job right, to carry that responsibility well, to do the 200 experiments on board, to take care of the life and the vehicle, but also to notice the experience. It's so rare amongst all 8.3 billion of us here on the surface. Only a tiny fraction have ever done what we were doing. And so in amongst all the science and the technology, the necessity also to share it and allow other people to not just be entertained, but to perhaps think differently about their own possibilities by looking at what's right on the edge of human capability.
Right, and Chris, when you talk about changing technologies, new improved technologies, what are these core technologies? Is it the fuel we use, the engines we use, the vehicles that take us out there?
It is all of those things, but I think that the two biggest changes weren't on your list. And one is small, high-speed ability to make decisions, early versions of machine intelligence, integrated artificial intelligence, so that things can be far more automated. When I flew on my various space flights, the machines were still very pilot-related. They had very primitive computers on the space shuttle, and even the Soyuz that I was the pilot of on my third flight, still very much an analog vehicle. So the one is computing power. The second is three-dimensional positioning. GPS, and then all of the refinements of the global positioning system, sat-nav, that has allowed us to be so much more precise in what we're doing. And that has led, with both of those things, to reusable rockets. And those two words used to be an oxymoron. Yeah. Those two words go together now, to the point that SpaceX and other companies are working on 100% reusable space flight. And that's brand new. And if you can reuse all the equipment, then of course the price drops, and that furthers the opportunity for everybody even more.
And the fact that we can use this equipment, these rockets again, Chris, can we attribute that to the fact that private companies have taken over space exploration to a large extent?
Private companies for profit have always built the spaceships. What has changed is that the technology is now proven, so that the government doesn't have to make every single decision because they are the ones who are willing to accept the risk. Now it is proven enough that a private citizen can buy a space flight, like Jared Isaacman has done a couple times, from a private company and fly in space. That's not a policy decision. That is an improvement in technology decision. And that's what is radically changing it. It's opening up the markets just differently than it could have been 30, 50, 60 years ago.
Now, there are many countries and agencies that are planning robotic missions, human missions as well, to the moon, to Mars. China successfully sent a mission to the far side of the moon and brought back moon rock samples from there. I mean, what are your thoughts on these latest planned expeditions to the moon and to Mars?
When I'm trying to predict the future, and I rely on studying the past. And we have had several opportunities in human history to move into a new continent, but they're rare. You know, you trace back to humans got to the Americas maybe after the last ice age, about 20,000 years ago. We got to New Zealand, not a continent, but a huge island, about only 800 years ago. We only got to Antarctica really about 100 years ago, maybe 110 years ago. And what the moon is essentially is an untapped continent, like each one of those. And what enabled all of those was improvements of technology. So I try and study how did we do? What did we do wrong? It's why I'm working with King Charles at Astra. It's why, or the Astra Carta. It's why I'm leading the Open Lunar Foundation on lunar settlement policy. What did we do wrong in all of those previous human levels of exploration and settlement? And what could we maybe learn from it so that we can do better now, as we are right on the cusp of not just sending a few early explorers to the moon, robotic and human, but actually starting to land there with the intention to stay and take advantage of that huge untapped resource that has no biosphere, no life at all. You're not disrupting any life. So it's kind of an amazing opportunity. Doesn't happen very often. And so how we do it, I think, is really important.
Right, and Chris, let's look at what's been recently discovered. I mean, Chinese scientists discovered that the mantle on the far side of the moon is cooler than on the near side of the moon. We also had NASA record vibrations of quakes on Mars. I mean, what does this tell you about the future for humans living on the planet or on the moon?
I think it actually teaches us mostly about Earth. If you are a doctor and you only ever looked at one human being, you're going to draw some very precise and very inaccurate conclusions as to what's possible in Homo sapiens, in human beings. If we just look at Earth and we try and understand how planets work and therefore what the future is going to bring, we're going to draw a lot of false conclusions. So by being able to study other planets, and we've seen now with our best telescopes over 6,000 planets orbiting other stars, but to be able to go to the moon and bring back samples, as several countries have, including China, we learned what the history of the moon was and the fact that it was torn from Earth, 4.5 billion years ago. By landing on Mars, as several countries have, we're starting to understand why, if Mars was so Earth-like 4 billion years ago, with thick atmosphere and oceans, what changed? Right. And why is it contracting and having little Mars quakes now? And what is the future then for an Earth-Moon economic system and eventually an Earth-Moon-Mars economic system? We're just in early technological access to those things. A lot of it's driven by science. A lot of it is driven by our ability to invent the machines that'll safely get us there. So it's a really fascinating time to be alive.
Right, and as I said in the introduction, you've now also turned your talents to writing fiction. It started with the Apollo Murders, a thriller set in the Cold War. Then there was a sequel called The Defector, and your latest book is called Final Orbit. So talk to us about life as an author and how you made that transition.
Well, it was my first love, writing. It's what I like best in school. I've always been an inveterate reader. I'm always reading, one technical book and one sort of thriller book. Being able to access some other human being's thoughts in detail, the way that reading does, I find extremely valuable. It's how I learn most of the things I know. But I knew if I got a university degree in English, they weren't going to let me command a spaceship. So it's been wonderful to get to this stage of life with having been a fighter pilot and a test pilot and a thrice flown astronaut, to now be able to take all that life experience. I've written 3 nonfiction books, but there's a tremendous freedom in writing fiction, thriller fiction, the kind of the genre that I love the best. You get into the reality of what is it truly like for all the different astronauts and cosmonauts on board. And I love being able to weave that into real history in a way that people learn a bunch about it, but also see just what might have happened.
Chris Hadfield, good luck with the book, and thanks so much for being with us.
Thank you, Anand. Nice to speak with you.
Thank you, and that's it for this edition of The Heat. I'm Anand Naidu in Washington.